All right. Sorry I didn't get that going earlier, the recording. So you're told that a increase of 1 cricket chirp per minute corresponded to a quarter of a degree Fahrenheit in temperature. So that gives you rise over run, a quarter degree on top corresponds to 1 cricket chirp on the bottom. Because the cricket chirp is your run. It's your horizontal variable. And that winds up with a slope of a quarter. And one way we talked about, we now have a slope of a quarter. We now have a point on the graph, 20 cricket chirps and 42 degrees. So we have y minus y0 equals mx minus x0, where x0, y0 is a point on our line. In our case, our y variable is t minus y0. That's the y coordinate associated with my point. That is 42. Equals. M is the slope, 1/4. My x variable is c minus the c coordinate of my point, which is 20. So this gives me 1/4 c minus 5. And so t is going to be 1/4 c minus 5 plus 42. That gives me t is 1/4 c plus 37. So this right here is t as a function of c. All right. Oh, wait a minute here. We have a typo. That is supposed to be a 4 here. If you recorded 100 chirps per minute, what is the approximate temperature? So the temperature associated with 100 chirps per minute is going to be 1/4 times 100 plus 37 equals 1/4 of 100, 25, plus 37 is 62 degrees Fahrenheit. Right? Not much different than is out there right now, probably.
A little chilly outside.
Yeah, it's getting there. Yeah, summer's over here. Yeah. With my granddaughter, we went to a pumpkin patch yesterday afternoon. That was awesome. Went to this huge one out near Omaha. I mean, it's enormous.
Is it Valid?
Vallis, you been to Vallis?
Yeah, I've been to Valid.
Yeah, that's where.
Did you eat the caramel apple, the dip one?
I didn't eat caramel apples, but I wanted one. I ate plenty of village. I had a turkey leg.
Oh, yeah.
I had a turkey leg. Those are good.
Yeah, that's when I'll break the diet for sure.
Oh man, I broke the diet. Yeah. But if you haven't been to one of these pumpkin patches, there's a lot more than pumpkins. It's like a theme park on farm themes, but all kinds of fun stuff there. So if it's 80 degrees outside, how many chirps per minute would you expect? So in part B, you had the number of chirps and it asked you the temperature. Here it's saying you have the temperature. How many chirps would you expect? So our function is T is 14 C plus 37. So our temperature in this part C is 80. Equals 1/4 C plus 37. So 80 minus 30. Oh, hold on a second. 80 minus 37 equals 1/4 of C. Okay. 80 minus 37 is 43. I like what I'm solving for to be on the left. So I'm going to do C is going to be 4 times 43, and that's 172 chirps per minute. Now, I don't know how they count 172 chirps. That's like 3%. Chirpy, chirpy, chirpy. Right? But evidently they probably have a chirpometer, right? Somebody has probably made a millionaire made themselves a millionaire inventing a chirpometer. Or they probably make a recording and they can slow it down and maybe count that way. There's another one. The state of simpleton. We need a state with a tax code this simple right now. The state of simpleton has a linear tax schedule that requires the resident to pay $424 on $12,000 annual taxable income and $1,331 on $30,250 in taxable income. Don't get wrapped up in the numbers. You have 2 points on the tax schedule. That's what you need to get wrapped up in. So part A asked, find a function T of X that gives the amount of taxes due on X dollars. So this is T, this is X dollars of income, taxable income. Right? What do we know about this? Well, we have 2 points on the line. You pay $424 on $12,000. So down here you pay $424. This is in dollars over here on $12,000. So X, let me do here. This is X in thousands of dollars. That's what we're going to and then you have 1331 on 3250, 30,000. 0.25. So you have this point on the tax schedule and this point on the tax schedule. By the way, you'd be surprised how many people cannot read a United States tax schedule. They are not so complicated. What's complicated is coming up with the amount you actually need to look up on set tables. Right? So I have 2 points on the curve. Find a function t of x. What do I need to find a linear function? I should say slope, right? You're told that it's linear. So the slope is rise over run. You don't have to write that every time, but I think it's helpful here. In my 2 points, how much does it rise? The rise is between there and there. Right? So it's 1331 up there minus 424. Right? Divided by the run. The run is going to be 30.25 in thousands minus 12, which is 18.25. And you got the numbers over there. It's 907 divided by 18.25. And I actually, excuse me, I actually changed the units in my example here, but I did not change the units on this calculation. So instead of I'm going to have 0.1825. So I'm going to move the decimal place over 3 times. That's 49.69. 4.969. Actually 969. Let's round it to 3 decimal places. 4.970. That's the slope. 4.97. And by the way, what you're doing here is fine as long as you tell the reader what your x is. Actually, the problem says x should be in dollars. I made x thousands of dollars. And so you know what? I'm going to make these two the same. This is my bad. Here's what we're going to do. Sorry, guys. This is too confusing. We're not going to make x in thousands of dollars. We're going to just make x dollars, just like it says in the problem. I shouldn't have changed that. And then here, you're just going to have to add some zeros. So we're going to make this over here. With 1331, that is associated with 30,250. Minus 12,000. That gives you 18,250. And that is approximately this 0.0497. That's the slope. And the reason why I changed all that, and I apologize, is that you're specified in the problem that x is the number of dollars in income. And on my graph, to save some writing, I made x thousands of dollars instead of the number of dollars. And that could be confusing. So I don't know if that's confusing. Oh, so I have x, I have the slope, and I have points. So now I can use either my point slope formula, or I can use the other technique that we talked about. Right? The other technique was you start with y equals mx plus b. Or in this case, t equals m x plus b. And we're going to use one of our points. Let's use this point right here. This is the point 12,424. 12,424. So the taxes due are 424 equal. The slope 0.0497. The x value associated with that is 12,000. And I need the y-intercept b. So b is going to be 424 minus 0.0497 times 12,000. What is that going to be? Let's go to our calculator. $424 minus 12,000 times 0.0497. Minus $172.40. So it's minus. Okay. And so our final function is t equals 0.0497x minus 172.40. And actually, if you see up here in the, that comes out to actually 172.38 if you get technical about it. Right. So actually, you should let the calculator do the rounding. All right. How much taxes are due on 40,625? So the taxes due on 40,625 is 0.0497 times that number minus 172.38. Right? And that's going to come out to what's over there? $1,846.68. Oh, in this class, you always round your final answer only. Don't round things along the way and then replug them in. Use your calculator to keep those decimal places. But your final answers are always rounded to the nearest penny if they are in dollars. And you're going to find that in pretty much all your business classes. Although, listen to those teachers, not me. Whatever the teacher says, okay? Right. I know on federal income tax returns, you can round to the nearest dollar. You can skip the pennies. All right. Got here. Oh, we're not going to do that one today. We're going to do that one today. All right. See you. Come by and see me if you want help with your test. You want some enlightenment. You want some examples. I can point those out in the book because we have plenty in the book. I'll see you guys hopefully on bright and early on Monday. Not too early. Yes. 2 in the afternoon. You're not one of my bright and early. Bye, Giannis.
Bye.
Thanks, Miller.
Nah.